Cambridge Primary Science. 4th grade. Activity book. Sound. 4.1 Sound travels through materials. Sounds come from sources. Words to learn. Source. Travel. Sunita hears an aeroplane passing overhead. The aeroplane is a source of sound. Sunita hears the sound when it enters her ears. The sound can travel from the aeroplane to Sunita's ears. Activity 4.1. Make a tin can telephone. You will need a piece of string about 3 meters long, 2 empty tin cans. Look at the pictures to see what to do. Single quote, single quote. Use the string to join the 2 tin cans. Give 1 tin can to a partner. Keep the other one yourself. Walk away from your partner until the string is tight. Talk softly into your tin can. Your partner should listen into their tin can. Did your partner hear your voice? This is how the tin can telephone works. Sound travels through different materials. Sound travels through materials, like string. Sound can travel through different kinds of materials. Questions. 1. What is the source of sound in the tin can telephone? 2. Which materials does the sound travel through in the tin can telephone? 3. Why did the Native American people lie with one ear in the ground to listen for enemies or animals to hunt? What you have learnt. Sounds come from sources. Sound travels from a source to our ears. Sounds travels through materials like string. Talk about it. Why do you think outer space is completely silent? 4.2 Sound travels through different materials. Activity 4.2. You will need a source of sound, like a ticking clock, a balloon filled with water, a block of wood, or a wooden door. Investigating how sound travels through different materials. Sound travels better through some materials than through others. Look at the pictures to see what to do. Remember to stand the same distance away from the clock each time. Air. Cover one ear. Can you hear the clock ticking? 2. Water. Cover one ear with your hand and one ear with a balloon filled with water. Can you hear the clock ticking? 3. Wood. Listen carefully. How well did you hear the sound each time? Draw a table like the one shown in the table. Record how well you heard the sound through the different materials. Cover one ear with your hand and put the other ear against a block of wood. Can you hear the clock ticking? Show how loud the sound was by using ticks. Equals soft. Material. Equals louder, square root, square root, square root. Equals loudest. Loudness of sound. Air. Water. Wood. Questions. 1. Which material did you hear the sound best through? 2. How did you make the investigation a fair test? Challenge. Describe how you could investigate whether sound travels best through wood, plastic, or metal. What you have learnt. Sound travels through different materials. Sound travels through solids, liquids, and gases. Sound travels best through solids. Whales communicate with each other underwater. The sounds travel a very long way. Talk about it. Why do you think sound travels best through solids? 4.3 How sound travels. Sound travels through different materials. But how does sound travel? Activity 4.3. Jumping rice. Put the plastic wrap over the top of the jar. Keep the wrap in place with an elastic band. Sprinkle a few rice grains over the wrap. Hit the side of the jar with the pencil. What happens to the rice? Hold the tin tray close to the jar and bang it with a spoon. What happens to the rice? Words to learn. Vibrate. Vibration. You will need plastic wrap, elastic bands, rice grains, an empty glass jar, a metal baking tray, a wooden spoon, a pencil. Predict what will happen if you clap your hands next to the jar. Try it out. Was your prediction correct? Vibrations cause sounds. Sounds are made when things vibrate. A vibration is a very quick movement back and forth. You often cannot see vibrations, but can feel them. Hold your hand in the middle of your throat and hum a tune. You will feel the vibrations and hear the sound. You can see these guitar strings vibrate. Sound travels because vibrations travel. Why did the rice grains in activity 4.3 move? You see the rice grains move. The plastic wrap vibrates. The rice grains vibrate and move. The tin tray vibrates when you hit it. The jar vibrates when you hit it. The vibrations travel through the jar to the plastic wrap. The air around the tin tray vibrates. Questions. 1. Did you hear a sound when you hit the jar? Why? 2. Think back to the tin can telephone. Which materials vibrated when you used the telephone? What you have learned. Vibrating objects make sounds. Vibrations move from the vibrating object through materials. We hear sounds when the vibrations reach our ears. Sound travels because vibrations travel. Talk about it. How could you stop the sound traveling in a tin can telephone? 4.4 Loud and soft sounds. How can we make sound louder? Look at the picture. Do you think the sound is loud or soft? What makes the sound louder? Words to learn: loud, soft. A motorbike starting up is a loud sound. A whisper is a soft sound. Activity 4.4. Listening to sound through a tube. Hold the clock next to my ear so that I can listen to the tick. You will need a long cardboard tube, a source of sound. Look at the pictures. Copy what the children in the pictures are doing. Can you hear the clock now? Is it louder or softer than before? Can you hear the clock now? 3. Questions. 1. Was the sound of the clock louder or softer when you moved the clock further from your ear? Why do you think that this happened? Use the words vibrations, travel and air in your answer. 2. Was the sound louder through the tube? Why do you this happened? Think that. Activity 4.4b. Planning a fair test for loud and soft sounds. Think of a question about loud and soft sounds. Plan a fair test to find the answer to your question using everyday materials. In your plan, list the materials you would use and the steps you would take. Explain how you would make it a fair test. Suggest how you would present your results. Question. Look at the picture. How do you think the music was made louder? This is the oldest type of music player with no electronic parts. What you have learned: sounds can be loud or soft. Trapping the sound vibrations makes the sound louder. Talk about it. How do people in your community deal with loud sounds? 4.5 Sound volume. A sound is louder when the vibrations are bigger. The volume of a sound is how loud or soft it is. Words to learn: volume, decibel. Sound level meter. A decibel, dB, is the unit we use to measure the volume of sound. These are the volumes of some everyday sounds. Very loud sounds, louder than 85 decibels, can damage our ears. dB, 20, 20, 60, 70, 80, 100,000, 110, 120, 220. Measuring sound volume. Some people play loud music. How can you find out how loud the music is? You can use a sound level meter. 746. A sound level meter. Activity 4.5. Measuring sounds. Think of some sounds to measure. For example, clapping hands, blowing a whistle. You will need a sound level meter. Ways to make different sounds. Slamming a door or the class talking. Predict which sound will be loudest and which will be softest. Plan how you will measure the sounds. How will you make sure that the test is fair? Plan how you will record the sounds. Will you use a table or a bar chart? Challenges. 1. Predict the volume of silence in decibels. 2. How can you find out if your prediction is true? Questions. 1. Which sound was loudest? 2. Which sound was softest? 3. Were your predictions correct? 4. Explain why some sounds are loud and other sounds are soft. What you have learned: small vibrations cause soft sounds. Large vibrations cause loud sounds. Talk about it. How does a sound level meter measure? The volume of a sound is how loud or soft the sound is. We measure sound in units called decibels. Volume. We can use a sound level meter to measure the volume of sounds. 4.6 Muffling sounds. There are some sounds that we don't like, or sounds that are too loud. We can muffle sounds that we don't want. The sound of this jackhammer is very loud to hear. This means that we make the sounds quieter and less clear. Loud sounds can hurt our ears. Some people work in very noisy places. They need to protect their ears. They wear ear defenders to muffle sound. Words to learn. Muffle silences. Ear defenders. 2. The sound inside an aeroplane can be very loud. Ways to muffle sound. We fit silences to cars, trucks and motorcycles to muffle the sounds of their engines. In buildings we use carpets and curtains to stop noise. Sometimes the spaces between walls are filled with materials that don't let noise through. 4. Sound. The volume of sound from an electric hand drill could damage ears. This motorbike silencer muffles the sounds of the engine. Activity 4.6. Finding out which material muffles sound the best. You will need different materials: a source of sound, a shoe box with lid, a sound level meter, if available. Predict which material will muffle sound the best. Place the sound source in the box. Pack one of the materials around the sound source in the box. Then place the lid on the box. Stand about 1 meter away from the box and listen to the sound. Is the sound loud or soft? Sound source. Put the lid on the shoe box and stand 1 meter away. Newspaper. Shoe box. If you have a sound level meter, measure the sound volume and record it. Repeat the activity with the other materials. Present your results in a table. Questions. Which material muffled sound the best? Why do you think so? 2. Was your prediction correct? 3. Is this investigation a fair test? Explain why or why not. What you have learned. Some materials can muffle sounds well. Some materials are not good at muffling sounds. Talk about it. Why can it be dangerous to listen to music through earphones while riding your bicycle? 4.7 High and low sounds. Pitch. A whistle makes a high-pitched sound. Thunder makes a low-pitched sound. High. Slow vibrations produce a low-pitched. Words to learn. Low. Pitch. Tune. String instrument pluck. Factors. Sound. Fast vibrations produce a high-pitched sound. Pitch is not the same as volume. The volume describes how loud or soft the sound is. For example, the sound of thunder is low-pitched but also loud. Some sounds have such a high pitch or such a low pitch that we cannot hear them. Elephants make very low-pitched sounds that we cannot hear. But other elephants can hear these sounds up to 7.5 kilometers away. String instruments. A guitar is a string instrument. Some strings are thicker than others. The guitar has pegs that you can use to make the string tighter or looser. You can also make the strings shorter by pressing them down. These things change the pitch of the notes. When you tune a string instrument, you change the pitch of the strings so that it is right for each string. Pegs. Bats make high-pitched sounds that we cannot hear. Thick and thin strings. 4. Sound. Activity 4.7. Making high-pitched and low-pitched sounds on a guitar. Pluck the thick strings and the thin strings. Which strings make a higher-pitched note? Tighten one of the strings by turning the peg. You will need a guitar or other string instrument. Now pluck the string. Does the sound have a higher or a lower pitch than before? Loosen the string by turning the peg the other way. Predict the pitch of the sound when you pluck the string. Now pluck the string. Was your prediction correct? Now press the strings down on the neck with the fingers of one hand while you pluck the strings with your other hand. How does the pitch change? Questions. 1. Which factors affect the pitch of the sound of a stringed instrument? 2. Which has a higher pitch? A long string or a short string? 3. Which has a lower pitch? A thin string or a thick string? What you have learnt. The pitch of a sound is how high or how low that sound is. Talk about it. How could you tune a guitar to make the pitch of the notes sound right? The faster the vibrations, the higher the pitch of the sound. You can raise the pitch on a stringed instrument by making the string thinner, shorter, or tighter. 999. 4.8 Pitch on percussion instruments. Percussion instruments include drums, shakers, and rattles. Drums are one of the oldest and simplest musical instruments. Words to learn percussion. Musical instruments. To make a sound with a percussion instrument, like a drum, you have to hit or shake it. Hitting or shaking it sets up vibrations in the air and you make a sound. 77,097. A dav is a drum from the Middle East. Look at each of these instruments. Which of these have you seen and heard? Tambourine, maracas, bongos. Some drums have a skin stretched over the top. When stretch the skin tightly, it makes the vibrations quicker. The drums in the steel band are made from metal. Oil drums. The drums in the steel band are different sizes. When you hit the top of one of the drums, the metal top vibrates and makes a sound. The air trapped in the drum makes the sound loud. Questions. 1. In the steel band, which drums do you think make high-pitched sounds and which make low-pitched sounds? 2. How does the steel band play a tune? 3. How could you change the pitch of the sound on the African drum in the picture? What you have learnt. Banging a small drum makes fast vibrations and a higher-pitched note. Tightening the drum skin also gives a higher-pitched note. Talk about it. What could you use to make your own percussion band? 4.9 Having fun with wind instruments. Each of these pictures shows a woodwind instrument. Some have one pipe and others have many pipes. Words to learn. Woodwind instrument. People make music from woodwind instruments by blowing down or across the tops of hollow pipes. This makes the air vibrate inside the pipe to make a sound. A recorder from the UK. The recorder has one pipe. You have to change the length of air in the pipe to make high and low-pitched notes. You can block the air holes in the pipe to do this. A shakuhachi from Japan. A titsi from China. A didgeridoo from Australia. Sometimes woodwind instruments consist of a line of pipes of different lengths. These are panpipes from Bolivia. Activity 4.9. Making sounds by blowing. Line your bottles up on a table. You will need 8 glass bottles or jars of the same size. Water and food coloring a large jug. You are going to make your own wind instrument and use it to change the pitch of the sound. Pour water into the jug and color it with a few drops of food coloring. Pour water into each bottle like in the picture. Pour a little water into this bottle. Pour a little more water into this bottle. This bottle must be almost full. Column of air. 1, 2, 3, 4, 5, 6, 7, 8. Gently blow across the top of each of the bottles 1 to 3. Did you make sounds? Are the sounds from blowing across each of the 3 bottles the same pitch? Predict what pitch of sounds you will make when you blow across the other bottles. Collect evidence to test your prediction. What you have learnt. The pipe of a wind instrument traps air. Blowing across the top of the pipe makes the air vibrate, which makes a sound. Talk about it. How would you play the instruments shown on these 2 pages. The longer the column of air is, the lower the pitch of the sound. 4. Check your progress. Match up the words in column A with their meanings in column B. A. Volume. Vibrate. Source. Muffle. B. To make sounds less loud and less clear. Where something comes from. A unit for measuring sound. How high or low a sound is. Pitch. Decibel. 2. 3. How loud or soft a sound is. To shake very quickly backwards and forwards. Write down whether each of these sentences is true or false. A. You measure the volume of sound with a loudspeaker. B. You play a guitar by plucking the strings. C. Sound only travels through air. D. Soft materials are better than hard materials for muffling sound. E. Sound travels best through solids. Look at the pictures of these musical instruments. A. B. 4. Which instrument A, B or C can you play by? I. Plucking. E. Hitting. E. Blowing. B. How can you change the pitch of the note with instrument B? Describe each sound as high, low, soft or loud. A. A whisper. B. A bird singing. C. A cow mooing. D. An ambulance siren. 5. Pfizer and Halima will use this apparatus to investigate how sound travels through solids, liquids and gases. 77. 12. A. B. 8. 76. Which container is full of gas? Which contains a solid and which contains a liquid? B. Why does each container have to be the same size? C. What will they use the clock for? D. How will they collect their evidence? E. What conclusion will they reach?